All right, so here's the agenda for today's class. We're going to be counting atoms, and then we're going to be working on doing that the entire class. So we're going to be taking notes. Before we do that, what I want to say is, remember we talked about when elements come together, they form what? When compounds, like hydrogen and oxygen coming together forms water. That's a compound. It's two elements that come together, and when they come together and form a compound, that's considered a formula. And coming together to form that formula, they have different or same properties as what they were before they combined. Different. That's a chemical compound, meaning a chemical change. They have different properties. So we're going to take notes talking about counting atoms so that we can further go on and talk about formulas and compounds and things of that nature. So, as I write, you too should be writing. You should have a blank sheet of paper. Your title for this is going to be titled Counting Atoms. And it may get blurry, but it will focus as we go. So counting atom notes. Could everyone see that? Okay. Starting off, every compound, and what did I just say a compound is also known as? Starts with an F. Edison. Formula. Every compound, also known as a formula, represents a molecule with, everyone, yes? Yes. With a certain number of atoms. Remember, atoms are the smallest form of matter. Atoms together give us our element. So they have a certain number of atoms in each molecule. I'm going to underline the word compound and formula because that's the important thing in this statement. Everyone with me still? Okay. As we go through, we'll be writing some examples. So, for example, CO2. Notice how I wrote that. It's capital C, capital O because it's combining what? Rogolin. One carbon, two oxygens, but the two elements are carbon and oxygen. This number must be written small, and it must be written as a subscript. What does the word sub mean? Duran. Use your another pencil. What does the word sub mean? Christasia, below. What does the word script mean? Raise your hand. Writing. So obviously a subscript means below writing or writing below. So your subscript is a number that has to be written below your element. It always belongs to the element that it's linked to. It's like an earring. Pay attention here. It doesn't belong to the C. It only belongs to the O because it's combined to the O. When there is not a subscript there, we assume that number to be what? 1. Very good. This entire thing is considered a what? Compound or formula. What's the name of it? That's water? CO2 is water? Water didn't make this. H2O is water. There's no outcome of this. I want to know what the name of CO2 is. CO2 is carbon dioxide. H2O is Water. So this is called carbon dioxide. All right? Now we want to talk about that subscript. The subscript, and I'm going to underline that because that's the important thing in this statement. So the subscript number in each formula tells you how many of each type of atom is in the what? Is in the what? Formula or compound. I'm going to put another little star underneath that star and put if there is no subscript, then the number of atoms in the formula is what? 1. Example. Using carbon dioxide, that number 2 is the what? Subscript. So here let's write count the atoms for CO2. And before I move on there, I just want to add to subscript equals the small number. So when we count the atoms, we first need to list the elements that make up the formula. So what elements make up the formula? Carbon and oxygen. Raise your hand. How many carbons are there? Ray? 1. Raise your hand. How many oxygens are there? Jamil? 2. So the total number of atoms equals what? 3. So there are 3 atoms in carbon dioxide. Everyone with me? I mean, as far as with me as understanding. Okay. Now, sometimes your formula has parentheses, and that's going to be important as well. So let's jot information about that. when there are parentheses and I'm underlining that because that's important here. This means all of the atoms in the parentheses are multiplied by the number outside of the parentheses. Are we good with as far as understanding so far? Anything before the parentheses as far as understanding, because we haven't done an example for the parentheses. When you're writing your notes, are you writing them like me? Yes. Okay, so to make sure that they are in order, make sure you're writing them like me. All right, example. Mg is what? Magnesium. Then we have an open parenthesis. And we have O, which is oxygen. H is hydrogen. Close parenthesis and a subscript 2. This formula is called magnesium hydroxide. Use what you have to write now. So now we need to count the atoms. So we're going to count the atoms for magnesium hydroxide, or MgOH2. Raise your hand and tell me the first thing we should do. Duran. English. Okay, examine them. I'm looking at them. Simon, please help us out with English. List the elements in the formula. What are the elements that we have? We have magnesium, so we have Mg, oxygen, and hydrogen. Oh, yes. I know. There's a certain way I have to do it because this thing is very sensitive. I know, but it's going to flop. 1 second. All right, raise your hand. How many magnesiums do we have? Simon? How many? 1. Raise your hand. How many oxygens do we have, Rogerlyn? 2, because it's outside the parentheses. Oxygen is in the parentheses, and outside of the parentheses you have 2. Raise your hand. How many hydrogens do you have, Ladrika? 2. So our total number of atoms, everyone, is 5. 5. 2, 4, 5. Everyone have that? I mean, understanding. Okay, as I'm writing, you should be writing. Do not wait till I finish writing for you to write. If you need to go to the back, go to the back. If you have some room on the bottom of your paper, keep writing and write the words more examples. I'm going to flip my paper over because I have no more room. Hydroxide. Jenny, you have to stay with me when I'm writing, and you should be all the way down here. Magnesium hydroxide. This is the purpose of me writing the notes with you so that you're all caught up. All right. So like I said, you're writing more examples. And we're going to do 1, 2, 3, 4. We're going to do quite a few. So let's start by writing here. Our first example is going to be CaCO3. This is calcium carbonate, chalk. And what's the first thing that we do? Raise your hand. Let's give Duran another try. What's the first thing we do? I'm looking at them. Thank you. List the elements. What are they? Everyone, give me the first one. Calcium. Then what? That's not cobalt. Cobalt's capital C, lowercase o. Carbon and oxygen. Raise your hand. How many calcium do we have? Jamil, raise your hand. Devin, how many carbons do we have? 1. Bryson, how many oxygens do we have? 3. So our total equals 5. Look at them on my top drawer. Top left drawer. All right. And I'm going to draw a line here to save space, and I'm going to do another one over here. Top left drawer on my desk. Pull it all the way out. Top drawer. Okay, pull it all the way out. All right. The next one is C9H8O4. This is aspirin. What's the first thing we need to do? Jayla. List the elements. What are they? Jayla. Carbon, hydrogen, and oxygen. How many carbon do we have, Jenny? 9. How many hydrogens, Eddie? 8. How many oxygen do we have, Drew? 4. What's our total?
21.
Cut it out. I'm going to write a couple more, and you all are going to write them, and then you're going to figure them out on your own. The next one I'm going to write is C2H4O2. This is vinegar. Then I'm going to write, quiet, C2H5NO2 3. Try nitrobulene. H5. And I'll write one more, which is CaH2PO4 2. And that's calcium dihydrogen phosphate. I know them. CaH2PO4 2. This is calcium dihydrogen phosphate. A type of calcium. All right, I want to give you a minute to work on those. And then we're going to come together. It goes to whatever's in the parentheses. You should be working through them. I shouldn't hear you all talking. All right. So, let's see. Aaliyah, walk us through C2H4O2. Tell me what to do. Tell me what they are. What is C? No, what is C? What's H? And what's O? Very good. And continue. Okay. Uh-huh. Okay. And our total? All right. Anyone have any questions on that? All right. Very good. Let me have Aaron for C2H5NO2 3. Walk me through it. Anyone confused? Our total? Well, let's add it up, Drika. 2 plus 5 is 7 plus 3, 10 plus 6. Well, you read your notes. It doesn't say add, it says multiply. Read your notes. What's the number? Very good. Question? You want to do the next one? Okay. Okay. I want to add one more afterwards, but I'm going to work on this one first. Go ahead, Jayla. Very good. Calcium, hydrogen, phosphorus, and oxygen. All right, how many does calcium have? Very good. 2 times 2 is 4. There's 1 that's here times 2 is 2. And oxygen, 4 times 2 is 8. How much? 15. What if we had, I want to throw a little monkey wrench in the game. What if we had HOH2 2. This is peroxide. Just want to verify. All right, work through that. That's a little tricky. No, this is not peroxide. It's hydrogen hydroxide, which I'm not really sure what it is. I have to look it up. But I do want to work through this formula. All right, Simon, you ready? What do we do? List the elements. What are they? Hydrogen and oxygen. How many hydrogen, Simon? How'd you get that? 1 here. 2 times 2. So 2 times 2 hydrogen plus 1 more gives us 5. Very good. How many oxygen? 2. There's 1 in the parentheses times 2 gives us 2. What's the total? 7. Is everyone good? All right. Then we have one other part of our notes to add. So down here, when there's our notes. When formulas are written, everyone should be with me because I'm saying it and writing it with you. When formulas are written with, Jamil, what are you doing? You should be writing. What do you mean all right as if you just figured out that that's what you should be doing in class? Get a pen out. Get to writing and get a pen out now. When formulas are written with a coefficient, and you're like, this is science, why are we talking about math? Because science and math are very closely related, as you can see through the formulas we just did. So when formulas are written with a coefficient in front of the formula, so when formulas are written with a coefficient in front of the formula, this means that there are that number of molecules. What do you normally do in math when there's a coefficient? Multiply what? By that coefficient. So, in other words, the entire formula is multiplied by the what? Coefficient. Very good. The coefficient is what type of number? Now, the coefficient is what type of number? Is it little? No. It's a big number. In front of what? Actually, I'm not even going to put big number in front. I'm just going to say big number because in math, it is the big number also. And we can say in front of a variable. And yeah, you know what? I'm going to put in front of the formula. Sorry. In front of formula. It's not, no, it's not part of the formula because actually, if for example, you don't need to write this. If I have, well, actually, let me put this here. Before I do that, I'm going to get to your point, your question in just a second, Rogerlyn. But I do want you all to write this example as soon as this gets clear. So, for example, if we have 3 SiO2, which is silica or silicon dioxide, and that is what's in a quartz stone. This number here is the what? This is the coefficient. Everyone have that? So, in other words, if I have that 3 SiO2, you don't need to write this. What this is saying is this equals SiO2 plus SiO2 plus another SiO2. So it's not part of the formula. It's saying that we have 3 SiO2 molecules. You understand? Just like in math, I'll do this. If you have 2x, what is that saying? You have x plus x. You have 2 x's. Oh, that's a 2. Thank you. That's x squared. If I had 3x, then it would be I'd have x plus x plus x. Understand? So in this situation, the 3, like your notes say, goes to the entire formula. So if you look at your notes, it says, when a formula is written with a coefficient in front of the formula, this means that there are that many number of molecules. The entire formula is multiplied by the coefficient, which means that 3 SiO2, 3 times SiO2 means you have SiO2 3 times. You understand that? Okay, so when we're here and we need to count our atoms, so let's write count atoms for SiO2. We still follow the same step. The first step, which is what? List your elements. So what are they? Silicone and oxygen. Now, let's say how many we have without the coefficient first. How many silicone? 1. But with the coefficient, we need to do what? Multiply it by 3, because it says its formula is multiplied by the coefficient. Oxygen without the coefficient? 2. But with the coefficient, we must do what? Multiply it by 3. So 1 times 3 gives us
3.
1 times 3 gives us 3. 2 times 3 gives us 6. Our total is 6 times 3? 6 plus 3? 9. We have to add those together after we do that. All right, let's write more examples, and you can use this small area on the bottom because it's not going to take much space. More examples. We'll do, and I'm going to make these 2 lines down here double up so that I don't have to use an extra sheet of paper, because this is all we're writing is these last 2 examples. All right, so one is, and I'm going to write them both and then you do it. One is 4Fe2O3, and I'll write it on here so you can see it. So one of them is 4Fe2O3. And the other one is 6C4H10. Why don't you write it? You can't see this. I'm going to move it over. I want you to work at them first. Yes, that is a 10. All right, now that you've written, work at them so I can put them on my note sheet. All right. So for our give me a moment. For our 4Fe2O3, Drika, start us off.
Okay. Fe.
We have, I didn't mean to put this line here. We have Fe, and what else? What else do we have?
Oxygen.
And oxygen.
Then you put 4.
Hold on, let me get rid of this line so it doesn't confuse anyone. All right, so Fe we have what?
We have 2.
Like that. Wires in the way. Okay, so she says Fe we have 2.
O has 3.
Fe only has 2.
No, I haven't got.
Let's go through the whole thing. So we're going to multiply it by 4.
And that equals 8.
Good.
And then
Let me explain that. So for those of you that didn't see it, without the coefficient, Fe has 2. Multiply it by the coefficient gives us 8. Now oxygen. Drika.
Oxygen has 3.
Uh-huh.
Then you multiply by 14.
We multiply it also by 4, and we get
12.
12.
And then when you add those two numbers together, your total will equal 20.
All right, Brian, work through this one for us.
Okay. So first we list down the elements.
What are they?
Carbon and hydrogen.
Carbon and hydrogen. Uh-oh. 1 second, let me let it focus. Come on. Okay. How many carbon do I have without the coefficient? How many carbon do I have without the coefficient? 4. And what do I do with the coefficient? Multiply it by 6, which gives us 24. Hydrogen without the coefficient? What do I do with the coefficient? What do I get? My total is what? 84. Any questions? Okay. Then you have a sheet in front of you that you got from the basket that Ladrika looks like this. All right? You are going to be working through this. Make sure you put your name on it. I don't know why your number fell down here. It should be up here. This one should be up there, but you can put your number there. That's fine. Do not write here. Brian, don't move on top of me. This is for me only. Make sure you follow these steps. Here's your example. So it says write down the different elements, which I did. Write down the number of atoms in each element. Add and write the total. Pay attention to your elements. Pay attention to your parentheses, your coefficients. Use your notes. You need to do each box, and if you flip over to the back, there is a back. Any questions? Okay, then go ahead and get to work, and this concludes the video lesson.